Hello, I'm going to go over one of the systems of three linear equations where it has the three equations and the three variables. So let's write down this example. So we have x plus y minus 2z equals 7. Second equation is negative x plus 4y plus 3z equals 2. Last equation is 2x minus 3y plus 2z equals negative 2. There are three equations here. The goal in this problem is to first pick one variable to eliminate from all three equations. Okay. And this is the same example that I did in the notes that is linked in the class calendar. It's also linked in the chapter 1 folder of Schoology. So you could follow along on that as you watch this video. If you need a printout of those notes, please let me know. So I'm going to choose to eliminate the x values from all three of the equations. And that's using elimination method. So I'm looking for opposites. I can see here that the x's are opposite in equation 1 and 2. So I'm going to go ahead and rewrite equation 1 and 2 by themselves, but side by side, everything lined up. Y is lined up, Z is lined up, equal sign, so on. And since the x's are already opposites, I don't need to do any multiplying, so I can just add the two equations and eliminate the x's. So those cancel out, leaving me with 5y, because this is a 1, plus 1z, or you can just write z, equals 9. So now I need to do that again, and I know that I have to use equation 3. Because I haven't used equation 3 yet. And again, it's because I have to eliminate x from all three equations. I've already eliminated the x's from the first two. I just need to eliminate it from the third one. Now, that means one of the equations is going to be used again. So you're either going to pair equation 3 with equation 1 or equation 2. So I'm going to go ahead and pair it with equation 2, and I'll highlight that so that you can see that there. And I can see that my x's are not opposite. So I have to eliminate x's again because that's what I eliminated the first time around. So I know that I need these two x terms to be opposite in equation 2 and 3. And in order to do that, I'm going to have to do some multiplying. So I'm going to have to multiply this second equation by 2. If I do that, if I go equation 2 here, if I multiply that to each term, so 2 times negative x, 2 times 4y, 2 times 3z, and 2 times 2. And you'll see that as I go to recopy equation 3 underneath the newly created equation 2, that my x's are now opposites, and therefore they will cancel out. What that's going to do is going to give me another equation. That equation is going to be 5y plus 8z equals 2. So call this equation 4 and equation 5. Just trying to stay organized here because there's a lot going on here. So what we have here is we have two equations with just two variables. This is similar to what we did prior. So if I go back in our notes, we did a process called the elimination method. So the elimination method was these types of problems where you just had two variables. Well, that's what we now have. So from this point on in the problem, it becomes a problem just like we did a few days prior to learning this, where it was the systems of equations elimination method. So let me go back to where I was. Okay. So we have now these two equations. So what I'm going to do with these two equations is I'm going to eliminate yet another variable. I'm going to choose to eliminate the y's, and that's because if you look at the y's, they're both 5y. So it'd be really easy to make them be opposites by multiplying one of them by a -1. If I multiply this by -1, it'll make those y's opposites, and then you'll see what happens at that point. Okay, so equation 4, I'm going to keep it exactly the same. So a lot of rewriting, so be really careful making sure you rewrite everything correctly. Equation 5, we have -5y minus 8z equals -2. Now, if you're wondering where did that equation 5 come from, it came from multiplying this -1 to every single term on both sides of the equation. Okay. The last thing that I'm going to do here to eliminate my y's is I'm going to add the two equations together. You can see that the y's are now canceled, and I'm left with -7z equals 7. And the reason why that's so nice is because now we only have a z left, and I can divide both sides by -7 to get a z value of -1. So we now have one of our variables. Now our goal here is to have an x value, a y value, and a z value, and writing it as what we call an ordered triple, similar to an ordered pair, except there's 3 numbers. So I know so far that I have my z. My z value is taken care of. And we know that if we have one value, we can always find more values by plugging it in. Now, for the z value of -1, you don't want to plug it back into one of these original problems, because if you plug in the value of z, you're going to be left with 2 variables. So I want to plug this z in where I only have 2 variables. So that's going to be plugging this into equation 4 or 5. So I'm going to go ahead and I'll just plug it into equation 4. So that's going to be 5y plus 1 times z, which is -1, equals 9. Doing a little simplifying, I get 5y minus 1 equals 9, and you're going to see that all I have left is a y. So now I can add 1, divide by 5, and I now have my second variable. So now I have a y and a z. I have 2 of those variables. So since I have a y and a z, this is now where I'm going to go back, and I'm going to take these 2 values, and I'm going to plug them in to where I see those 2 variables, but I also see an x, which is equations 1, 2, or 3. So going back to one of the originals up here, where you have an x, y, and z, I can plug in a y. So I can plug in a y, I can plug in a z, and the only variable I'll be left with is an x. So you get to choose which equation you're going to plug it into. I'm going to choose that first one. So that's going to be x plus y. My y is 2, so x plus 2. Minus 2 times my z, which is -1, equals 7. So with a little simplifying, so I do my multiplication, so I get a plus 2. Combine like terms, subtract 4, and you get your x value of 3. And we always write our final answer as a ordered triple. X, Y, Z is the order, alphabetical order. So my final answer is 3, 2, -1. So there it is. If you need another example, please let me know. I have other examples linked in our chapter 1 folder of Schoology. Like I said, this exact problem is done in another set of notes in the chapter 1 folder of Schoology. If you need a printed copy, let me know. But I thought it would be great to go through it step by step with you so you could have a better understanding of how to do it. So let me know if you have any questions, and good luck with your practice.